What is Java? Java is a high-level programming language that is class-based, object-oriented, and designed to have as few implementation dependencies as possible. It is intended to let application developers write once, run anywhere, WORA, meaning that code that runs on one platform does not need to be recompiled to run on another. Java is used to develop mobile and desktop applications, games, and other software. Java is owned by Oracle Corporation, a multinational computer technology corporation. Oracle acquired Sun Microsystems, the original creator of Java, in 2010. Java is used for a variety of purposes, including the development of desktop applications, such as media players, text editors, and image editors. Web applications and dynamic websites. Mobile applications for Android smartphones and tablets. Enterprise applications, such as customer relationship management, CRM, systems and enterprise resource planning, ERP, systems. Scientific applications, such as simulation and modeling software. Video games and gaming engines. Embedded systems and Internet of Things, IoT, devices. Big data processing and cloud computing. Overall, Java is a versatile and widely used programming language. Why use Java? There are several reasons why Java is a popular choice among developers. Object-oriented programming. Java is an object-oriented language, meaning that it supports encapsulation, inheritance, and polymorphism. This makes it easier to write reusable, maintainable, and scalable code. Platform independent. Java code is compiled into bytecode, which can run on any device that has a Java Virtual Machine, JVM, installed. This means that Java applications can run on any platform without modification. Rich libraries. Java has a rich set of libraries and APIs, making it easier to develop complex applications quickly. Large community. Java has a large and active community of developers who contribute to open-source projects and provide support for each other. Secure. Java was designed with security in mind and has features such as type safety, automatic memory management, and security managers to ensure that applications are secure. Enterprise grade. Java is widely used in enterprise applications, such as e-commerce, banking, and finance. It is also used in cloud computing, big data processing, and other enterprise-level technologies. Familiar syntax. Java syntax is similar to C++, making it easier for developers who are already familiar with C++ to learn Java. Overall, Java offers a powerful, secure, and flexible environment for developing a wide range of applications. Java install. To install Java, follow these steps. Download the Java Development Kit, JDK, from the official Oracle website, http URL. Install the JDK by following the instructions provided with the downloaded file. Set the Java_home environment variable to the location of the JDK installation. This will allow Java applications to find the JDK when they are executed. Add the JDK's bin directory to your path environment variable. This will allow you to run Java commands from the command line. Verify the installation by opening a command prompt and running the following command. Java version. This should display the version of Java that is installed on your system. Once the JDK is installed, you can start developing Java applications and using Java tools. You may also want to install an integrated development environment, IDE, such as Eclipse or IntelliJ IDEA, to make it easier to write, debug, and run Java code. Java Quick Start. Here's a quick start guide for writing your first Java program. Install the Java Development Kit, JDK, as described in my previous answer. Open a text editor or an integrated development environment, IDE, such as Eclipse or IntelliJ IDEA. Create a new file and save it with a Java extension, for example, Hello World, Java. Enter the following code into the file. Public class Hello World, public static void main, string, args, system.out, print ln, hello, world. Compile the code by using the javac command in the terminal or command prompt, followed by the name of the file. Javac Hello World, Java. Run the code by using the Java command in the terminal or command prompt, followed by the name of the class, without the Java extension. Java Hello World. You should see the following output. Hello, world. This simple program demonstrates the basic structure of a Java program, including the use of a class, a main method, and a call to the print ln method to display text on the screen. From here, you can start exploring more advanced Java concepts and building more complex applications. Java syntax. Here is a brief overview of some basic Java syntax elements. Class. In Java, a class is a blueprint for creating objects. Classes define object data fields and methods, and can be used to encapsulate data and behavior. Method. A method is a block of code that performs a specific task. Methods are declared within a class and can be called from other parts of the program. Variables. Variables are used to store data in a program. Java supports several primitive data types, such as int, float, and boolean, and reference data types, such as objects and arrays. Data types. Java has two categories of data types, primitive and reference. Primitive data types include int, float, double, char, and boolean, while reference data types include objects and arrays. Operators. Java supports a variety of operators, including arithmetic, comparison, logical, and bitwise operators. Control flow. Java supports control flow statements, such as if, for, and while, that allow you to control the flow of execution in a program. Exception handling. Java provides built-in support for exception handling, which allows you to handle errors and exceptions that occur during the execution of a program. Comments. Comments are used to add documentation and information to your code. In Java, comments can be single-line or multi-line, and start with, or, asterisk, respectively. This is just a brief overview of the basic elements of Java syntax. Java is a large and complex language, and there is much more to learn beyond what is covered here. However, these basic elements should give you a good foundation for exploring the language further. The main method. The main method is the entry point of a Java program. It is a public static method that is called when the program is executed. The signature of the main method is as follows. Public static void main, string, args, your code here. The keyword public makes the method accessible from anywhere in the program. The keyword static allows the method to be called without creating an instance of the class. The keyword void specifies that the method does not return a value. The main method takes an array of string objects as its argument. The keyword public makes the method accessible from anywhere in the program. The keyword static allows the method to be called without creating an instance of the class. The keyword void specifies that the method does not return a value. The main method takes an array of string objects as its argument, which can be used to pass command line arguments to the program. Within the body of the main method, you can write code to perform the tasks of your program. This can include declaring variables, performing calculations, making decisions using control flow statements, and calling other methods. The main method is an essential part of every Java program, and it must be included in order for the program to be executed. When the program is started, the Java Virtual Machine, JVM, looks for the main method to start the program's execution. System.out, println. System.out, println, is a method in Java that is used to print a line of text to the console. The System.out object is an instance of the printStream class, which provides a way to print data to an output stream. The println method is used to print a line of text, followed by a new line character, to the console. Here is an example of how to use System.out, println, in a Java program. Public class main, public static void main, string, args, System.out, println, hello, world. When this program is executed, it will print the message, hello, world, to the console. The println method can also be used to print other data types, such as numbers and Boolean values, by converting them to strings automatically. The print method. The System.out, print method is similar to System.out, println, but it does not add a new line character after the output. This means that if you call System.out, print, multiple times in a row, the output will appear on the same line. Here is an example of how to use System.out, print, in a Java program. Public class main, public static void main, string, args, System.out, print, hello, System.out, print, world. When this program is executed, it will print the message, hello, world, to the Java comments. Java supports two types of comments, single-line comments and multi-line comments. Single-line comments start with 2 forward slashes, and continue until the end of the line. For example, this is a single-line comment. Multi-line comments start with a forward slash and an asterisk, and end with an asterisk and a forward slash, asterisk. For example, asterisk. This is a multi-line comment. It can span multiple lines. Asterisk. Comments are ignored by the Java compiler and are used to add explanations and annotations to the code. They are used to help other programmers understand the purpose and behavior of the code, and to provide reminders and notes to yourself. It's a good practice to include comments in your code, especially for complex or non-obvious sections of the code. Java variables. In Java, a variable is a named storage location for a value, which can be of a certain data type, such as int, double, char, etc. To declare a variable in Java, you use the following syntax. Data underscore type variable underscore name. For example, to declare an integer variable named age, you would use the following code. Int age. You can also initialize a variable when you declare it, by assigning a value to it. Int age equals 30. Here are some examples of declaring and initializing variables in Java. Int age equals 30. Double temperature equals 72.5. char grade equals A. String name equals John Doe. Boolean is valid equals true. Once a variable is declared and initialized, you can use it in your code by referring to its name. You can also change the value of a variable by assigning a new value to it. Age equals 31. It's important to choose meaningful and descriptive names for your variables, and to use a naming convention that makes it clear what type of data each variable holds. In Java, variable names typically start with a lowercase letter, and multiple words are separated by camel case. Java identifiers. In Java, an identifier is the name given to a variable, class, method, package, or any other named entity in the code. There are certain rules and conventions that must be followed when choosing an identifier name. Identifier names can consist of letters, digits, underscore characters, underscore, and dollar signs, dollar, but cannot start with a digit. Java is case sensitive, so age and age are considered to be different identifiers. Keywords, such as public, static, final, etc., cannot be used as identifiers. Java has a set of reserved words, such as int, double, char, etc., that cannot be used as identifiers. Java naming conventions suggest using descriptive and meaningful names for identifiers, using camel case for variable and method names, and using Pascal case for class and interface names. Here are some examples of valid and invalid Java identifiers. Valid. Age. Customer underscore name. Temp Celsius. Invalid. 123 age, starts with a digit. Public, reserved word. Char, reserved word. It's important to choose appropriate and meaningful names for your identifiers, as this makes the code easier to understand and maintain. Good naming conventions can greatly enhance the readability of the code. Making it easier for other developers to understand your code and making it easier for you to understand your code in the future. Java data types. Java has a number of built-in data types that can be used to represent different types of data, such as numbers, characters, and Boolean values. Here are some of the most commonly used data types in Java. Int represents a 32-bit integer value, for example int age equals 30. Double represents a 64-bit floating point value, for example double temperature equals 72.5. Char represents a single 16-bit Unicode character, for example char grade equals A. String represents a sequence of characters, for example string name equals John Doe. Boolean represents a logical value, either true or false, for example Boolean is valid equals true. In addition to these basic data types, Java also provides several advanced data types, such as arrays, objects, and more. When declaring a variable, it's important to choose the appropriate data type based on the type of data that the variable will be storing. It's also important to be mindful of the size and range of each data type, as using the wrong data type can lead to unexpected results or overflow errors. For example, using an int to represent a value that is too large for its range can cause an overflow error. While using a double for a value that requires a high degree of precision can result in rounding errors. Primitive data types. In Java, there are 8 primitive data types, which are the basic building blocks for all data in Java. These data types are predefined by the language and are not objects created from a class, unlike the non-primitive data types, such as string and array. Here are the 8 primitive data types in Java. Byte represents a 8-bit signed integer value. Short represents a 16-bit signed integer value. Int represents a 32-bit signed integer value. Long represents a 64-bit signed integer value. Float represents a 32-bit floating point value. Double represents a 64-bit floating point value. Char represents a 16-bit Unicode character. Boolean represents a logical value, either true or false. All primitive data types have a fixed size, and their values can be directly stored in memory. Primitive data types are used to represent simple values, such as numbers, characters, and Boolean values, and are more efficient than non-primitive data types, as they don't require the overhead of creating and managing objects. When declaring a primitive type variable, you must specify its type and its name, and you may also initialize it with a value. Int age equals 30. Double temperature equals 72.5. Char grade equals A. Boolean is valid equals true. It's important to choose the appropriate primitive data type based on the size and range of the data that you need to store, as well as the precision required for floating point values. Non-primitive data types. In Java, non-primitive data types are objects created from classes, as opposed to being predefined by the language like primitive data types. They are also known as reference data types because they hold a reference to the memory location of the object, rather than storing the object's data directly. Here are some of the most commonly used non-primitive data types in Java. String represents a sequence of characters, for example string name equals John Doe. Array represents a fixed size collection of elements of the same type, for example int numbers equals 1, 2, 3, 4, 5. Classes represents user-defined objects, for example a person class with properties such as name, age, and address. Interfaces represents a blueprint for classes, for example an animal interface with methods such as eat and sleep. Enums represents a fixed set of constant values, for example a days of the week enum with values such as Monday, Tuesday, etc. Non-primitive data types offer more flexibility and functionality than primitive data types, as they can store complex data structures and support inheritance, polymorphism, and encapsulation. However, they also have a larger memory footprint and require more processing time, as the Java Virtual Machine (JVM) must allocate memory for the objects and manage their lifecycle. When using non-primitive data types, it's important to keep in mind that they are reference data types, and that when you assign one non-primitive variable to another, both variables will refer to the same object in memory. To create a separate copy of the object, you must use the clone method or create a new object using the same data. Java typecasting. In Java, typecasting refers to the process of converting a value of one data type to another data type. There are two types of typecasting in Java. Implicit typecasting, also known as widening conversion. This occurs automatically when converting a value from a smaller data type to a larger data type. For example, converting an int to a long or a float to a double. Explicit typecasting, also known as narrowing conversion. This occurs when converting a value from a larger data type to a smaller data type. For example, converting a double to an int or a long to a short. Explicit typecasting is performed by placing the target data type in parentheses before the value that you want to convert, for example, int number equals int 3.14. Short age equals short 33. It's important to note that explicit typecasting can result in loss of data if the target data type is not large enough to store the original value. For example, if you convert a double with a value of 3.14 to an int, the fractional part will be lost, and the result will be 3. In general, it's recommended to use implicit typecasting whenever possible, and to perform explicit typecasting only when necessary, and after carefully considering the potential loss of data. Java operators. In Java, operators are symbols that perform specific operations on one or more operands, values or variables, and produce a result. Operators are used in expressions and statements to manipulate data, control flow, and perform arithmetic and logical operations. Here are some of the most commonly used operators in Java. Arithmetic operators perform basic arithmetic operations, such as addition, plus, subtraction, multiplication, division, and modulus, %. Assignment operators assign values to variables, such as equals, plus equals, 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 %equals. Comparison operators compare values and return a Boolean result, such as equals equals, equal to, equals, not equal to, greater than, less than, less than. Greater than equals, greater than or equal to, less than equals, less than or equal to. Logical operators perform Boolean operations, such as and, or. Not. Bitwise operators perform operations on the binary representation of integers, such as and, or, caret, XOR, tilde, not, less than, left shift, greater than, unsigned right shift. Ternary operator, a shorthand for an if-else statement, written as condition. Expression 1. Expression 2. Conditional operator evaluates an expression and returns one of two values based on a Boolean condition, written as expression 1. Expression 2. Expression 3. Each operator has a specific precedence, or priority, that determines the order in which operations are performed. Parentheses can be used to change the precedence and force operations to be performed in a specific order. It's important to understand the different operators and their precedence, as well as the data types that they can be used with, to write correct and efficient Java code. Java string functions. Java provides a number of built-in methods for working with strings, which are objects of the string class in Java. Some of the most commonly used string functions are: length returns the length of the string. Caret int index returns the character at the specified index in the string. Substring int begin index, int end index returns a new string that is a substring of this string. The substring begins at the specified begin index and extends to the character at index end index 1. Concat string street concatenates the specified string to the end of this string. Replace char old char, char new char replaces all occurrences of old char with new char. To uppercase converts all of the characters in this string to uppercase. To lowercase converts all of the characters in this string to lowercase. Trim returns to uppercase converts all of the characters in this string to uppercase. To lowercase converts all of the characters in this string to lowercase. Trim returns a copy of the string with leading and trailing white space removed. Split string regex splits this string around matches of the given regular expression. Equals. Object and object, compares this string to the specified object. The result is true if and only if the argument is not null and is a string object that represents the same sequence of characters as this object. These are just a few of the many string functions available in Java. It's important to understand the functionality of each method and to choose the right method for a specific task, in order to write efficient and effective Java code. Java math functions. The Java lang math class provides a number of mathematical functions and constants for performing various mathematical operations in Java. Some of the most commonly used math functions in Java include abs, double A, returns the absolute value of a double value. Max, double A, double B, returns the greater of two double values. Min, double A, double B, returns the smaller of two double values. Sqrt, double A, returns the square root of a double value. Pow, double A, double B, returns a raised to the power of b. Round, double A, returns the closest long to the argument. Seal, double A, returns the smallest double value that is greater than or equal to the argument and is equal to a mathematical integer. Floor, double A, returns the largest double value that is less than or equal to the argument and is equal to a mathematical integer. XB, double A, returns the value of e raised to the power of a double value. Log, double A, returns the natural logarithm, base e, of a double value. These are just a few examples of the functions available in the Java lang math class. It's important to understand the functionality of each method, as well as their limitations and limitations. In order to choose the right method for a specific task and to write efficient and effective Java code. Java real-life examples. Java is a widely used programming language and has many real-life applications. Some of the most common examples include enterprise applications. Java is commonly used to develop enterprise applications such as customer relationship management, CRM, systems, supply chain management, SCM, systems, and human resource management. Web applications. Java is a popular choice for building dynamic web applications, and is used to develop content management systems, e-commerce websites, and social networking sites. Mobile applications. Java is the official language for developing Android mobile apps, and is used to develop a wide range of applications, including games, utilities, and productivity tools. Financial applications. Java is widely used to develop financial applications, such as trading systems, risk management systems, and payment processing systems. Scientific applications. Java is used in scientific computing to develop simulations and models, analyze data, and perform mathematical calculations. Big data applications. Java is commonly used in big data projects, such as data processing, data analysis, and data visualization. Gaming. Java is used to develop desktop and mobile games, as well as gaming engines and game development tools. These are just a few examples of the many real-life applications of Java. The language's versatility, scalability, and security features make it a popular choice for a wide range of projects and industries. Some common problems faced by Java developers include memory management. Java's automatic memory management system can lead to memory leaks, causing the application to slow down or crash. Performance. Java applications can be slower than applications written in other programming languages, especially for complex operations or large amounts of data. Concurrency. Java's multi-threading capabilities can make it difficult to manage and synchronize threads, leading to race conditions and other concurrency-related problems. Debugging. Debugging complex Java applications can be challenging, especially when dealing with multiple threads and complex data structures. Security. Java applications are vulnerable to security threats, such as viruses, malware, and hacking attacks. Developers must be aware of these risks and implement appropriate security measures to protect their applications. Compatibility. Java applications can run into compatibility issues when used with different platforms or operating systems, or when upgrading to a new version of the Java platform. Learning curve. Java can be a complex language to learn, especially for those who are new to programming or have limited experience with object-oriented programming. These are some of the common challenges faced by Java developers. To overcome these problems, developers must have a strong understanding of the language and be familiar with best practices for developing secure, efficient, and scalable applications. Some examples of Java. Here are some examples of basic Java programs. Hello World. Public class Hello World. Public static void main, string, args. System.out. println, hello, world. Closing curly bracket. Closing curly bracket. Addition of two numbers. Import Java. util, scanner. Public class addition. Public static void main, string, args. Scanner input equals new scanner, system.in. System.out. println, enter two numbers. Int num1 equals input, next int. Int num2 equals input, next int. Int sum equals num1 plus num2. System.out. println, the sum of the numbers is, plus sum. Closing curly bracket. Closing curly bracket. Finding the factorial of a number. Import Java. util, scanner. Public class factorial. Public static void main, string, args. Scanner input equals new scanner, system.in. System.out. println, enter a number. Int num equals input, next int. Int factorial equals 1. For int I equals 1, I less than equals num, I plus plus. Factorial equals factorial asterisk I. Closing curly bracket. System.out. println, the factorial of the number is, plus factorial. Closing curly bracket. Closing curly bracket. Finding the maximum of two numbers. Import Java. util, scanner. Public class maximum. Public static void main, string, args. Scanner input equals new scanner, system.in. System.out. println, enter two numbers. Int num1 equals input, next int. Int num2 equals input, next int. Int max equals math.max, num1, num2. System.out. println, the maximum of the two numbers is, plus max. Closing curly bracket. Closing curly bracket. These are simple examples of Java programs, but they demonstrate some of the basic concepts of the language, including classes, methods, variables, input. Some Java string examples. Here are some examples of working with strings in Java. Concatenating strings. Public class concatenate strings. Public static void main, string, args. String first name equals, John. String last name equals, Doe. String full name equals first name plus last name. System.out, print ln, full name, plus full name. Closing curly bracket. Closing curly bracket. Finding the length of a string. Public class find string length. Public static void main, string, args. String message equals, hello, world. Int length equals message, length. System.out, print ln, the length of the string is, plus length. Closing curly bracket. Closing curly bracket. Comparing strings. Public class compare strings. Public static void main, string, args. String first string equals, hello. String second string equals, hello. Boolean equals first string, equals, second string. System.out, print ln, the strings are equal, plus equals. Boolean ignore case equals first string, equals ignore case, second string. System.out, print ln, the strings are equal, ignoring case, plus equals ignore case. Closing curly bracket. Closing curly bracket. Substring extraction. Public class extract substring. Public static void main, string, args. String message equals, hello, world. String substring equals message, substring, 7, 12. System.out, print ln, the extracted substring is, plus substring. Closing curly bracket. Closing curly bracket. These are a few examples of working with strings in Java. Java's string class provides many other useful methods for working with strings, including methods for searching, replacing, and formatting strings. Java if, else. Public class if else example. Public static void main, string, args. Int age equals 25. If age greater than equals 18. System.out, print ln, you are an adult. Else. System.out, print ln, you are not an adult. Closing curly bracket. Closing curly bracket. Closing curly bracket. In this example, we use the if statement to check whether the value of the age variable is greater than or equal to 18. If it is, the code inside the if block is executed, and the message, you are an adult, is printed to the console. If the condition is not met, the code inside the else block is executed, and the message, you are not an adult, is printed instead. The if and else statements can be combined in more complex ways to handle multiple conditions. For example, you can use else if to specify additional conditions. Public class if else if example. Public static void main, string, args. Int grade equals 80. If grade greater than equals 90. System.out, print ln, excellent. Else if grade greater than equals 80. System.out, print ln, good job. Else. System.out, print ln, study harder. Closing curly bracket. Closing curly bracket. Closing curly bracket. In this example, the code checks if the value of grade is greater than or equal to 90. If it is, the message, "Excellent," is printed. If it's not, the code checks if the value of grade is greater than or equal to 80. If it is, the message, "Good job," is printed. If neither of these conditions is met, the code inside the else block is executed, and the message, "Study harder," is printed. Java ternary operator. The ternary operator is a shorthand way to write simple if and else statements in Java. The general syntax of the ternary operator is as follows. Variable equals condition. Expression 1. Expression 2. Here, condition is a Boolean expression that is evaluated to determine whether to execute expression 1 or expression 2. If condition is true, expression 1 is executed and its value is returned. If condition is false, expression 2 is executed and its value is returned. Here's an example of using the ternary operator in Java. Public class ternary operator example. Public static void main, string, args. Int age equals 25. String result equals age greater than equals 18. You are an adult. You are not an adult. System.out. Print ln, result. Closing curly bracket. Closing curly bracket. In this example, the ternary operator is used to assign the value of either, you are an adult, or, you are not an adult, to the result variable, based on the value of age. If age greater than equals 18, result will be assigned, you are an adult. If not, result will be assigned, you are not an adult. The value of result is then printed to the console. Java switch statements. The switch statement in Java is used to select one of several alternative branches of code to execute based on the value of an expression. The general syntax of the switch statement is as follows. Switch, expression. Case value 1. Code to be executed if expression equals value 1. Break. Case value 2. Code to be executed if expression equals value 2. Break. Default. Code to be executed if expression is not equal to any of the values. Break. Closing curly bracket. Here, expression is an integer, char, string, or enumerated type expression, and value 1, value 2, etc. are constant values. The break statement is used to exit the switch statement. If a break statement is not used, execution continues to the next case. Here's an example of using the switch statement in Java. Public class switch statement example. Public static void main, string, args. Int day of week equals 4. Switch, day of week. Case 1. System.out. Print ln, Monday. Break. Case 2. System.out. Print ln, Tuesday. Break. Case 3. System.out. Print ln, Wednesday. Break. Case 4. System.out. Print ln example. Int day of week equals 4. Switch, day of week. Case 1. System.out. Print ln, Monday. Break. Case 2. System.out. Print ln, Tuesday. Break. Case 4. System.out. Print ln, Thursday. Break. Case 5. System.out. Print ln, Friday. Break. Default. System.out. Print ln, invalid day of the week. Break. Closing curly bracket. In this example, the break statement is used inside the switch statement to exit the switch statement and transfer control to the code outside the switch statement. The rest of the code inside the switch statement will not be executed, and Thursday will be printed to the console. Java loops. Java supports several types of loops to repeat a block of code multiple times. The most common loop structures are for loops. For loops are used to execute a block of code a specific number of times. They have three parts: an initialization statement, a termination condition, and an increment/decrement statement. For int I equals 0, I less than 10, I++. System.out. Print ln, I. Closing curly bracket. In this example, the for loop will print the numbers 0 to 9 to the console. While loops. While loops are used to execute a block of code repeatedly until a given condition is false. Int I equals 0. While I less than 10. System.out. Print ln, I. Closing curly bracket. In this example, the while loop will print the numbers 0 to 9 to the console. Do-while loops. Do-while loops are similar to while loops, but the code inside the loop is executed at least once before checking the termination condition. Int I equals 0. Do. System.out. Print ln, I. While I less than 10. In this example, the do-while loop will print the numbers 0 to 9 to the console, just like the while loop. It's important to use loops appropriately and to have a termination condition in place, to prevent infinite loops that can cause the program to hang or crash. Java arrays. Arrays in Java are a data structure that can store multiple values of the same data type. To declare an array in Java, you use the following syntax. Data type. Array name. For example, int numbers. You can also initialize an array at the time of declaration. Int numbers equals 1, 2, 3, 4, 5. To access an element in the array, you use the array name followed by the index of the element in square brackets. System.out. Print ln, numbers, 2. This would output 3. There are several useful methods available for arrays in Java, such as length to get the number of elements in the array, sort to sort the elements in the array, and fill to fill all elements of the array with a specific value. It's important to keep in mind that the index of an array starts from 0, so the last element in an array with n elements will be at index n1. Loop through an array. To loop through an array in Java, you can use a for loop. Here's an example. Int numbers equals 1, 2, 3, 4, 5. For int I equals 0, I less than numbers, length, I++. System.out. Print ln, numbers, I. Closing curly bracket. In this example, the for loop will iterate over the array numbers, starting from index 0 and ending at numbers, length 1. On each iteration, the value of the current element in the array is printed to the console. You can also use the enhanced for loop, also known as the for each loop, to loop through an array. Int numbers equals 1, 2, 3, 4, 5. For int number, numbers. System.out. print ln, number. Closing curly bracket. This for each loop is more concise and easier to read, as it eliminates the need to keep track of the array index and the termination condition. It simply iterates over each element in the array, in order, and the current element is stored in the variable number. Java multi-dimensional arrays. In Java, a multi-dimensional array is an array of arrays. It is used to store data in a tabular form, where each row represents a single record and each column represents a data field. To declare a two-dimensional array, you use two sets of square brackets. Int numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 9. To access an element in a two-dimensional array, you specify the row and column indices, separated by a comma. System.out. Print ln, numbers, 1, 2. This would output 6. You can also loop through a two-dimensional array using nested for loops. For int I equals 0, I less than numbers, length, I++. For int j equals 0, j less than numbers, I, length, j++. System.out. Print numbers, I, j, plus. Closing curly bracket. System.out. Print ln. Closing curly bracket. This code will output 1, 2, 3, 4, 5, 6, 7, 8, 9. In Java, multi-dimensional arrays can have any number of dimensions, not just two. The general syntax for declaring a multi-dimensional array with n dimensions is as follows. Data type. Array name. Where. Represents the number of dimensions. To access an element in a multi-dimensional array with n dimensions, you specify n indices, separated by commas. Java methods. In Java, a method is a block of code that performs a specific task. Methods are used to encapsulate code and make it reusable. A method can accept input parameters and return an output value. Here is an example of a simple Java method. Public static int square, int number. Return number. Closing curly bracket. This method takes an integer parameter number and returns its square. To call this method in another part of your code, you can use the following code. Int result equals square, 5. System.out. Print ln, result. This code would output 25. The general syntax for declaring a method in Java is as follows. Modify a return type method name, parameter list, method body. Where modifier is an optional keyword, such as public or private, that determines the visibility and accessibility of the method, return type is the data type of the value returned by the method. Method name is the name of the method, and parameter list is a comma-separated list of input parameters and the data types. Note that in Java, methods can also be defined inside classes. In that case, they are called member methods.